Here's problem 3623. A compound microscope is made with an objective lens, focal length of 0.9 centimeters, and an eyepiece lens, focal length of 1.1 centimeters. This should be F sub E. The lenses are separated by a distance of 10 centimeters. If an object is 1 centimeter in front of the objective lens, where will the final image of the eyepiece be located? Let's see what we got here. We actually have two lenses. We have an objective lens and an eyepiece lens. And we have an object that is 1 centimeter in front of the objective lens, where the distance between these lenses is actually 10 centimeters. If we had a ray coming from this object, it would come down through near the focal point and form an image in front of the eyepiece lens. And I can actually imagine that a ray coming through the center of this will converge at the same point, or a ray coming through this focal point will converge to the same point. So we end up with an image, a magnified image, that exists in front of the eyepiece lens. And that image will act as the object for the eyepiece. So as let's extend this lens a little bit more here. So we extend these lines here. They might come out like this to eventually reaching our eye over here. And as we look at this and follow these rays backwards, they may converge on a point, creating an image that is well magnified. So that's our purpose. That's the purpose of the compound microscope, where we have an objective focal point or focal length of 0.9 centimeters, and we have an eyepiece focal length of 1.1 centimeters. We wish to apply the thin lens formula for each of these lenses. So let's look at the objective. Object for the objective, 1 over that, plus the image distance for the objective is equal to 1 over the focal length of the objective. So 1 over the image distance for the objective will be 1 over the focal length, which is 0.9, minus 1 over the object distance, which is 1. So this is going to be equal to 10 ninths minus 9 ninths, or 1 ninth. So the object distance will be equal to 9 centimeters for the objective lens. The image distance would be 9 centimeters for the objective lens. So the image is indeed located 9 centimeters away from the objective lens. This image will act as the object for the eyepiece lens. So in other words, the eyepiece object distance is going to equal 10 minus the image distance from the objective lens. So that's going to be 10 minus 9, or 1 centimeter. So that image is indeed 1 centimeter in front of the eyepiece lens. And this image will act as the object for the eyepiece. So now we have 1 over the object distance plus 1 over the image distance for the eyepiece is equal to 1 over the focal length for the eyepiece. 1 over the image distance will equal 1 over the focal length, which is 1.1, minus 1 over the object distance, which is 1. This is going to give us 10 elevenths minus 11 elevenths, or a negative 1 11th. So Q for the eyepiece is going to equal a negative 11 centimeters. That would be the location of the image from the eyepiece. A negative 11 centimeters. The negative means it's not on the side of the outgoing rays, the rays that are actually hitting our eye. It is before that side, so it's on the same side as the incoming rays, and hence it's before the lens by 11 centimeters, which would actually be 1 centimeter in front of the objective lens. Okay, interesting to note further that the magnification for the objective, which is a negative Q objective over P objective, would be a negative 9 over 1, or a negative 9. And the magnification for the eyepiece, which is a negative Q eyepiece over P eyepiece, would be a negative 11 over 1, or 11. So our total magnification will be the product of these two, a negative 9 times 11, or a negative 99. That's our purpose for this compound microscope, is to have a great magnification of a small object. And here our magnification is the negative 99, which means it's inverted, but it is 99 times its original size. So we can see it well magnified. But the location of our final image is a negative 11 centimeters in front of the eyepiece lens.